Hi, my name is Shelby McLean, and this is my presentation on Brachiosaurus, phylogeny, and key morphologies. Okay, so when talking about an organism's evolutionary process, it's important to know its phylogeny. Brachiosaurus is part of the order Sarcenia. It's not seen on this phylogeny chart, but it would be probably just right before this. And to be a part of this category, it's mostly dealing with the shape of the pelvis. And to have, as you can kind of see in this picture, the Sarcenia pelvis is more facing downwards, and the bones are kind of going in different directions. Okay, and then so the next group is sauropod. And to be in this category, it needs to be large in size, a long-necked, have a tail, and then a four-legged stance. It also needs to have to be an herbivore. And then the next couple of levels of distinction, I'm just going to tell you their names. It's Sauropoda, Merconia, and then Titanosauriforms. And then we get to the family Brachiosaurus. Okay, and then there's kind of been a debate over the proper name of this organism. In the 1900s, Brachiosaurus was named Brachiosaurus brachii by janensch, but was given a completely different name of Giraffian brachii by Paul in the 1988. Janensch gave his classification due to the dinosaur similarity to Brachiosaurus althorax. This species was discovered in Colorado in the United States, and Brachiosaurus brachii was discovered in Tangara, Tanzania. When Paul did his own comparison, he found many of the bone structures were analogous between Brachiosaurus brachii and Brachiosaurus althorax. However, there was enough distinction within the dorsal column and the trunk of the dinosaur that we were able to create a difference in genus, Giraffian and Brachiosaurus. Okay, so to better understand how these dinosaurs lived, it's important to take into account the environment that they lived in. The environment of the late Jurassic period was humid and subtropical. This environment gave rise to many life forms such as sauropods like Brachiosaurus, and the plants that they ate. The plants were palm-like trees like cypress, conifers, and ginkgos, and fern-like trees. Okay, these creatures filled the niche of eating plants off of high limbs of trees. This is a very similar niche to the modern-day giraffe. Brachiosaurus preferred to eat trees that had softer leaves, like ferns, over the tougher, woodier leaves found on conifers. However, they did consume enough food that they didn't really have too much of a preference. Using its 52 small pencil-like teeth to strip off the leaves from branches of trees, and its long neck to reach the top of these trees, Brachiosaurus was able to gain its energy. It has a gastrointestinal system more similar to birds than any other organism, and it's estimated that its stomach weighed about 2,480 kilograms. When the Brachiosaurus fossils were found, they found particular round stones in the chest. By comparing a chicken they kind of thought that these stones were swallowed to help grind down fibers found within their diet. In chickens, it's been reported that they've been reported to swallow sand to help the grinding process that occurs in the gizzard. And so paleontologists think that these stones perform a very similar function. Okay, so with the vertebra column, that's as long as this one is, one would think that it would weigh a lot. However, the weight is 2/3 lighter than the other bones. These bones were strong and flexible and very similar to the bones of the modern day bird. For this reason, the reason for this drastic weight is that the neck bones have multiple cavities and inner channels within them. Some of these cavities, scientists believe were for the lungs and kind of having air sacs, very similar to how birds' lungs are, and for veins. And I'll go into that a little bit more on the veins. And this was a pulmonary vascular branching system. The capillaries can rupture if there's too much pressure. And since we're moving up this huge neck, it's kind of going against gravity. And so you're bound to have these ruptures happen. But evolutionary wise, they were able to evolve to have these kind of channels where they were able to kind of open it up. Hold on. Let's see. The pulmonary branching system can be characterized by large bore arteries that open directly into broad capillary beds, thus creating a buffer system within the neck. To further assist the movement of blood, Brachiosaurus had a huge 4-chamber heart that was able to pump blood to extreme heights. With this system, oxygen was able to be transported throughout the whole organism. Though technically there is no fossil evidence showing lungs and veins could be are part of this system, scientists are able to draw these conclusions by looking at the descendants of dinosaurs, such as reptiles and birds. Okay, and let's see. Its major form of defense against predators was pretty simple. Be bigger than what the predator can fit in its mouth. A full-grown Brachiosaurus weighed 26 to 38 tons. With this, the young were the key target for predators. They were still small enough for predators like Allosaurus to eat. However, a lot of smaller carnivores were able to eat sauropods once they died. Overall, the species didn't fall to much predation and had a long lifespan of 100 years. Unfortunately, due to its very large size, its mobility was severely hindered. Any movement aside from standing and walking straight was very strenuous on the Brachiosaurus, and it took them a long time to be able to make turns. Its movement is predicted to have been very slow, giving off an illusion of grace and fluidity. The movement of the front limbs is often described as an inverted pendulum motion, which you can kind of see in this picture over here. Okay, so for my conclusion, to sum it up, this icon of the Jurassic period has the phylogeny of Sarcenia, sauropod, Neosauropod, Marconia, Brachiosauri, and Brachii. Some of its features that helped it survive during the Jurassic period are its long neck that helped to reach the tops of trees, and the organs that helped support this appendage in order to obtain the greatest amount of energy from plants. Its large size helped it prevent predators from attacking it, which was helpful since its mobility was hindered by its size. And this is my presentation.